All right, moving on to our third page of notes. This is our triangle side splitter theorem. So what would happen if we move the segment in the triangle? As in, no longer at midpoints, but somewhere else along those sides. So we're getting either closer or further away from the third side that we reference with our triangles. So it looks like a dilation with a scale factor that is something other than 2 or 1/2. We're not doubling or we're not cutting things in half. And that's where the side splitter comes in. The sides of the scaled images are no longer a 1-to-2 relationship, but they are indeed proportional. So we're going to be using proportions. Proportions are two equal fractions. All right, so therefore, if a segment in a triangle is parallel to the third side, that means this segment, this blue one, is parallel to the third side because this is considered a first side, this is a second side, those are the ones that it intersects. The third side is the one that it's parallel to. So if a segment is parallel to the third side, it will create proportional sides, and this segment is called a side splitter. So a mid segment is a special type of side splitter. Okay, so very similar. All right, so we're going to use this concept to solve for x in the following diagram. So in this diagram, we'll see that PQ is parallel to BC, and that means that the ratio between these pieces is equal to the ratio between those pieces. So we're going to be able to create a proportion. You'll see x over 8 over x, 8 over x equals 12 over 18, 12 over 18. The key to creating our proportions is to make sure that we're consistent with the pattern that we're using. So with proportions, you'll see that I've begun already. We're going to cross multiply to solve. So that means the product of the extremes is equal to the product of the means. That's what I've demonstrated right here. Multiply your 8 times 18 to get 144, and then we'll divide both sides by 12. And that's how we'll find that x equals 12. Done. Very simple. We can create proportions in a very flexible manner as long as, again, we're consistent with the pattern that we create. So there's lots of variations of this proportion that we could have created. Instead of 8 over x, we could have started with x first, done x over 8, but then we would have to pair it up with 18 over 12, making sure we're consistent with that pattern. So please pause this video in order to allow yourself time to write these down. These are some of the variations that you will see. The one that we started with in that example was taking a top measure over a bottom measure, and it will equal the corresponding top measure over the bottom measure. We can, as I said, flip that upside down, and we can simply say, let's take the top piece over, the bottom piece over the top piece, and that's going to equal the bottom over the top. We can mix this up a little bit, still working with those pieces. And we can just say the left piece over the right piece. In other words, if I'm up here, I would do 8 over 12. That's a left over a right. That can equal x over 18, a left over a right. What you want to make sure you're doing is being consistent with your pattern, that if you start at the top left, it goes with the top right. Top left, a bottom left, bottom right. Just stay consistent. And it doesn't matter if you start with the left or the right first. We can do right over left, right over left. All right, so these all focus on parts, the little pieces that are created by that side splitter. Next, we're going to talk about working with the actual whole triangles. So when we're working with the whole triangles, we need to think about little triangle over big triangle. So I'm going to pull all these little boxes out of the way. There we go. And that is some sort of segment of the big triangle versus the little triangle. So when we're looking at this picture up here, the little triangle is up here. So it would be 8 over 8 plus x. I would need to use the measure of the whole segment A and B, not just the small part on the bottom. We need to make sure we're working with triangles. So the relationship is always still there. That would represent our scale factor. We might also reverse that and do a little triangle measure over a little triangle measure, and then pair it up with the corresponding big triangle measures. So make sure you get all of this down on your notes. It's very important to have all those combinations listed so that you can use this as a reference when you go to do your assignments. If you need to pause the video, please do so to make sure everyone has a chance to write this down. All right, now you're going to work with some practice problems. I'm going to reveal some of the work that I've done with problem number 7, and then I'd like you to get started and see how you do. So for number 7, in the diagram that we're given, I'll reveal it in a moment. I've written all over it. EF is parallel to AB, so now we have our side splitter identified. We're going to fill in the measures that were given, the 42, the 15, and the 30. And our goal is to find the length of FB. So the first thing I do is I fill in my picture. And hopefully I can move this guy out of the way. There we go. So here's my picture. I filled in the measures that I was given, and I could easily find a missing piece, AE. I knew AC was 42 and CE was 15. So I subtracted those two in order to find the measure of 26. Now that I have all the measures that I need, I can do top over bottom, left over right, and I can easily find the measure of X, which you can kind of make out at the bottom. All right, so here's my work on how I solved for my missing measure. I decided to go with top over bottom, and so I did 15 over 27 equals 30 over X, and I cross multiplied. That helped me find X equals 54, and thankfully FB was labeled as X, so once I found X, I knew I was done with the problem. All right, take a stab at a few more of these problems. I'd like for you to pick at least 2 more, and I would strongly suggest problem number 9. And with that, I am going to display the answer on the next page so that you can take a look at it. It'll be similar to a problem on our homework, and it does require factoring. So try them out. Good luck, everybody.